Hello everyone. Welcome to your online class of physics of class 8. I hope you all will be fine. Students, in my previous video I explained to you lesson number 1. So today in this video I will explain you the remaining part of lesson number 1. So let's begin our class. So change of state. We know that matter exists in 3 different states, that is solid, liquid and gas. The process of change from one state to another state, either by absorption or rejection of heat at a constant temperature, is called change of state. Means the process of change of state from one state to another state, either by absorption or by rejection of heat at a constant temperature, is called the change of state. Now change of solid into liquid or vice versa. When a solid is heated, it changes into its liquid at a fixed temperature, and this process is called melting or fusion. The reverse happens when this liquid is cooled. The liquid freezes into solid at the same fixed temperature, and this process is called freezing. Means when a solid is heated, it changes into liquid at a fixed temperature, and that is known as melting. And the reverse happens when this liquid is cooled. The liquid freezes into solid at the same fixed temperature, and that is known as freezing. Now change of liquid into gas. When a liquid is heated, it changes into vapor or gas at a fixed temperature, that is known as boiling. And the reverse happens when this vapor is cooled. Vapor condenses into liquid at that same temperature, and that is known as condensation. Okay, here you can see in this figure, solid when changes into liquid by absorption of heat is known as melting, and when this liquid is cooled and it again changes into solid, that is known as freezing, and this happens by the rejection of heat. The same way, when a liquid absorbs heat, it changes into gas, that is known as vaporization, and when this gas changes into a liquid on rejection of heat, that is known as condensation. Okay. Now, in some cases, a solid on heating directly changes into its vapor or gaseous state, that is known as sublimation. Means without changing into liquid, the gas directly changes into the solid directly changes into gas, that is known as sublimation. And if reverse happens, the gas on being cooled directly changes into solid, that is known as deposition. Okay, now these changes, it may be noted that the change of state of a substance occur at a fixed temperature, and during the process the quantity of heat given to or taken from the substance does not cause a change in its temperature. This heat is called latent heat because it is not manifested by any change in temperature. Means when at a fixed temperature a substance changes its state, and during the process the quantity of heat given out or taken the substance by the substance or to the substance, it does not change its temperature. Means it only changes the state, and that heat is known as latent heat. Okay, now melting. The change from solid state to liquid state on heating at a fixed temperature is called melting. The temperature at which a solid changes into liquid without further increase in temperature is called the melting point. Means at the temperature at which a solid changes into liquid without further increase in temperature, that is known as melting point. For example, ice at 0 degree Celsius melts to form water, and at 0 degree Celsius. Means ice at 0 degree Celsius will melt to water at 0 degree Celsius. Okay. Now freezing. The change from liquid state to solid state on cooling at a fixed temperature by rejecting heat is called freezing. The temperature at which a liquid changes into solid without further decrease in temperature is called the freezing point. For example, water at 0 degree Celsius freezes to form ice, that is solid, at 0 degree Celsius by rejecting heat. Okay, this is freezing. Now, do you know the amount of heat rejected during freezing of a substance is same as the amount of heat absorbed during melting for the same mass of a substance. Second one, the amount of heat absorbed or rejected during the change of state for a unit mass of substance is called the specific latent heat, and it is measured in joule per kilogram. Third, water expands on freezing, whereas lead and wax, etc., contract on freezing. Melting point of ice decreases with increase of pressure on it, but the melting point of wax increases with increase of pressure on it. Fifth, the melting point of ice decreases when salt is added to it. This mixture of salt added to ice is called the freezing mixture, and it is used for preparing kulfis. Okay, now vaporization or boiling. The change from liquid state to gaseous state on heating at a constant temperature by absorption of heat is called vaporization or boiling. Means the change from liquid to gaseous state on heating at a constant temperature by the absorption of heat, that is known as boiling or vaporization. The temperature at which liquid changes into vapor without further increase in temperature is called the boiling point. For example, water at 100 degrees Celsius changes to steam at 100 degrees Celsius. Okay. Now condensation. The change from vapor state to liquid state at a constant temperature on rejecting heat is called condensation. Means the change from vapor state to liquid state at a constant temperature on rejecting heat is called condensation. The temperature at which the vapor changes into liquid without any further decrease in temperature is called the condensation point of vapor. For example, steam at 100 degrees Celsius condenses to water at 100 degrees Celsius on cooling, that is by rejecting heat. Okay. Now, do you know? First, for a substance, the boiling point and the condensation point are same. For example, boiling point of water is 100 degrees Celsius and the condensation point of steam is also 100 degrees Celsius. Means at 100 degrees Celsius, water boils, and at the same temperature, the steam condenses to form water at 100 degrees Celsius only. Now, the amount of heat absorbed or during the change from liquid to vapor state or from vapor state to liquid state is same for the mass of the substance. Now third, all liquids expand on heating. Fourth, the boiling point of a liquid increases with the increase of pressure on it. The boiling point increases with the increase of pressure on it. This is why it is difficult to cook vegetables at the mountains where pressure is low, but it is easy to cook vegetables in a pressure cooker in which pressure is increased by keeping the water vapor inside the cooker. Fifth, the boiling point of a liquid increases when impurities are added to it. Means if boiling point increases if impurities are added to the liquid. The boiling point and heat absorbed for change of state from liquid to vapor for some liquids are given in the following table. You can read this table. Now, evaporation is another process by which a liquid changes into vapor. The change of state from liquid to vapor at all temperatures from the surface of a liquid is called evaporation. It is noted that evaporation takes place at all temperatures, but vaporization takes place only at a fixed temperature, which is the boiling point of the liquid. Means evaporation takes place at all the temperature, but vaporization takes place at only fixed temperature, that is the boiling point of the liquid. Second one is evaporation is a slow and gradual process, whereas vaporization is a rapid and violent process. Third, evaporation takes place only at the surface of the liquid, whereas vaporization takes place over the entire liquid. Fourth, vaporization has cooling effect, but vaporization does not produce cooling. The process of evaporation can be demonstrated by the following activity. So you can read this activity. Rate of evaporation. The rate of evaporation of a liquid depends mainly on the following factors, that is, the temperature of a liquid, second, the area of the exposed surface, third, nature of liquid, flow of air above the liquid, and the presence of humidity. So first one is temperature of a liquid. A wet cloth dries up on a hot day much faster than on a cold day. Thus, the rate of evaporation is higher if the temperature of liquid is high. Second, the area of the exposed surface. A cloth dries up faster if it is spread out, if it is folded up. Thus, the rate of evaporation increases if the area of the surface exposed increases. Nature of a liquid. Volatile liquids with low boiling point, such as alcohol, spirit, ether, etc., evaporate much faster than water. This is why volatile liquids are stored in tightly closed bottles. Fourth, the flow of air above the liquid. If air is blown above the liquid surface, it moves away the molecules of a liquid from the surface with it. So the liquid evaporates more quickly. This is why to cool the milk we blow air above it. Fifth one is the presence of humidity. In dry air, evaporation is faster than in humid air. This is why wet clothes dry faster in summer days than in rainy season. Now applications of evaporation. In summer, water gets cooled in an earthen pot. The reason is that water seeps out on surface through the pores in the pot and evaporates. The heat required for evaporation is taken from water inside the pot, which therefore gets cooled. Okay, so that's why water is kept in earthen pot in summer days. Now, second one is doctors advise to put the strips of wet cloth on the forehead of a patient having high fever because because the reason is that water of the strips evaporates during evaporation. Water takes heat from the body of the patient and thus the temperature of the body decreases. Third, we often pour tea in a saucer to cool it faster. In the saucer, the surface area increases and evaporation becomes faster. Fourth, evaporation of sweat from our body helps to maintain body temperature that at 37 degrees Celsius. When sweat evaporates, it requires heat when it takes away from our body. As a result, temperature falls to keep the body at 37 degrees Celsius. Now you can see here the table, difference between evaporation and boiling. You have to read this table. Okay. Now sublimation and deposition or solidification. Sublimation is a process by which a solid when heated directly changes into its vapor without first changing into liquid. Means the process by which a solid directly changes into its vapor state without changing in liquid. That is known as sublimation. And deposition, it is a process when vapor on cooling directly changes into solid without first changing into liquid. That is known as solidification or deposition. Okay. For example, when aluminium chloride, iodine, camphor, naphthalene and solid carbon dioxide are heated, they directly change into their vapor, and when their vapors are cooled, they change to into their solids. Now note, carbon dioxide gas when cooled convert into solid carbon dioxide, which is called dry ice. Okay, so what is dry ice? When carbon dioxide gas is cooled, converts into solid, and that is known as dry ice. Sometimes sublimation also takes place without heating. For example, naphthalene balls, which are used to protect woolen clothes from insects, directly changes into vapor, and with time they become small in size. The process of sublimation and deposition can be easily demonstrated by the following activity. You can read this activity by yourself. Okay. So this is all for today. Now what you have to do, you have to read the lesson properly because I already told you that 50% of your questions in unit test will be from inside the lesson and 50% from the exercise part. So you have to read both the lessons properly. Okay. Thank you.